The first application is budgeting. Suppose you are ordering pizzas and donuts for your birthday party. Now the pizza slice costs rupees 20 and a donut costs rupees 25. Now ideally you would have wanted unlimited pizzas and donuts, is it not? However, your budget is restricted to 1000. So how many of these items can you possibly order? Well, linear equations come to your rescue here. Taking x as the number of pizza slices and y as the number of donuts, we can create our own linear equation as 20x plus 25y equal to 1000. And now you can simply play around with the values, friends. Suppose I take x as 20, then substituting it in the equation, I'll get y as 24. That means 20 pizza slices and 24 donuts. Now suppose you want to increase the number of pizzas. No problem. You can simply substitute, say, another value. I have taken x as 30 and I have got 16 donuts. There are infinite more possibilities, friends. So the next time you're hosting a party, you know whose help to take. The second application is temperature conversion. So friends, recently I was in a call with a US friend who remarked that the temperature in his place was 95 degrees. Now I was shocked in the beginning, but then I realized that he was actually talking about the Fahrenheit scale. Now there is a very simple linear equation that connects Fahrenheit and Celsius. F minus 32 upon 9 is equal to C upon 5, where F and C are the temperatures in Fahrenheit and Celsius respectively. So putting the value of 95 Fahrenheit in my linear equation, I actually got C to be 35 degrees Celsius, which is pretty normal. So if someone says it's 41 Fahrenheit, you can substitute in the linear equation and your value of C will be 5 degrees Celsius. Now there is another linear equation which connects Kelvin scale and Celsius scale. K is equal to C plus 273. So you may ask, where is Kelvin scale used? Well friends, it's mainly used in the lighting applications and also in photography. So this linear equation comes very handy indeed. The third application is comparing rates. So friends, let's take the scenario of two coaching centers. Center A charges 200 rupees per class, whereas Center B charges 1440 per month. Both the centers take 8 classes per month. We want to know which center is more affordable. So let's take the help of linear equations. Taking x as the charge of center B for one class, we can make our own linear equation as 8x equal to 1440. So on simplification, we get x as 180. So center B charges rupees 180 only, which is much lesser than the charge of center A. So center B is obviously more affordable. So in this way, linear equations are extremely helpful for comparing rates. The fourth application is computer graphics. Friends, did you know that a linear equation actually represents a line in 2 dimensions and that it represents a plane in 3 dimensions? So linear equations are extremely useful in the positioning of an object, its rotation, shifting and sizing. So they are invaluable in weaving the magic behind graphics and animation. Last but not the least, perimeter and profit calculations. Friends, in school we have come across these formulae. Perimeter of rectangle, square, triangle and circle, right? But did you know that these are actually linear equations? Yes, these are all simple but very powerful linear equations which help us to find the perimeter of these figures. Moving on to profit and loss scenarios, here are the very commonly used linear equations that connect profit and loss with selling price and cost price. Friends, I hope you found the video informative and useful. If so, do like and share the video. Do consider subscribing to my channel. So till we meet again in the next video, take care.